continuous random variables continues in this section to look at expectation and variance. Remember that expectation is just the mean and the variance is the standard deviation squared. Again, we have patterns between our discrete random variables and our continuous random variables. So with our discrete random variables, in order to find e of x, we did the sum of our x value times its probability. To find e of x squared, we did the sum of x squared times the corresponding probability. And then we used those to find the variance of x, because it was e of x squared minus e of x all squared. Similarly, for continuous random variables, for e of x we've got our x times by our PDF, our f of x dx. And for e of x squared we need our x squared times our f of x dx. Both of these are being integrated. The variance is found in exactly the same way for both. So in this example we have our continuous random variable from before. So f of x is 1 over 21 x squared between x is 1 and 4 and 0 otherwise. And we're going to use this PDF to find the mean and variance of it. So the mean is e of x, which is the integral of x times f of x dx. So we are integrating x times our function, our f of x, or our PDF, which is 1 over 21x squared dx, and we're going between our lower limit and our upper limit between 1 and 4. So take the 1 over 21 outside and we've got x times x squared, so we're actually integrating x cubed dx. When we integrate that, increase the power by 1 and divide it by it, we get x to the power of 4 divided by 4. The 1 over the 21 is still there and the limits are 1 and 4. Substituting in those limits, we get 256 over 4 when we substitute in 4, and then minus 1 over 4 when we substitute the 1. Simplifying, we get 85 over 28. So the mean is, or e of x, is 3.04 to 3 significant figures. We want the mean and the variance, so we also have to find e of x squared first. So this time we're integrating x squared times our function f, or f of x dx. So we're integrating as before, but now the x has changed to an x squared, so it's x squared times 1 over 21 x squared dx. So we're actually integrating x to the power of 4. That becomes x to the power of 5 over 5 because we increase the power by 1 and divide by it. Substituting in, we get this. Simplifying, we get 341 over 35. So now we have both of the terms that we need in order to find the variance. So the variance of x is e of x squared, which is 341 over 35, minus e of x all squared, so it's the 85 over 28 all squared. It's better at this point to use the fraction rather than your rounded value if you've changed it to a decimal. That gives us 2067 over 3920, or 0.527 to 3 significant figures. So that is the way that you find the mean and the variance. You can also find the median and quartiles and other percentiles, like the 20th percentile or whatever, by integrating the PDF. So we know that the median would be halfway through the data. So if you integrate from the lower limit, whatever it would be, up to m of our function, we know that that's got to be equal to 0.5. So for this example we would be integrating 1 over 21x squared between the lower limit of 1 and m for our median, and we know that that equals 0.5, so we would end up with a equation in terms of m that we would need to solve. The lower quartiles you do exactly the same, except obviously the lower quartile is 25% or a quarter of the way through the data, so that one you integrate must equal 0.25, and then the upper quartile be 75% or 3/4 of the way through the data, so when you integrate that it must be equal to 0.75.